Okay, let's do some examples for equations for line in R3. The first part asks for point parallel form of a line through point 4, negative 1, 0, and vector I minus 2j plus k. Always remember you look for two things when trying to write an equation. One, a point which is given here. P is 4, negative 1, 0, and 2, a parallel vector. Well, in this case, parallel vector is given in ijk form, but, well, we can turn it into the vector form by, well, coefficient of I, 1 is the first component, coefficient of j, negative 2 is the second component, coefficient of k, 1 is the third component. Well, when you have p and t, then point parallel form is just p plus tv. While in this case it is p is 4, negative 1, 0 plus t times 1, negative 2, and 1. That's it. The second part asks for parametric form of the line through point 1, negative 1, 3 and parallel to a line given by this equation. Again, look for two equations, two things. One is a point. It is given 1, negative 1, 3, and 2, a parallel vector. Well, parallel vector is not given explicitly here. Instead of that, we are told that our line is parallel. So this is our line. This other line is xt equals to this thing. So these two are parallel. What does that mean? Well, first of all, note that this equation has all the information for that line. For example, you see that this is a parallel vector. This is a parallel vector. And this is a point on the second line. Okay, well, if it is parallel vector, it is parallel to the line, this line, but our line is also parallel to the line. That means that this vector is going to be parallel to our line. In other words, v equals to negative 2, 1, 5 is parallel to xt equals to 0, 1, 2 plus t negative 2, 1, 5. And our line is parallel. Our line is parallel to the same line. As a result of that, negative 2, 1, 5 is parallel to our line. It means that, well, we found v is negative 2, 1, and 5. And then the parametric equation, you see parametric equation has three equations. First, you put the coordinates of the point 1, negative 1, 3 plus t times first component of v, t times second component of v, and t times third component. Well, this is xt equals to negative 2t plus 1. Yt is t minus 1. And zt is 5t plus 3. And that's the parametric form for the given line. Okay, let's go to the third example. Parallel point form for the line through the origin. So the origin means that the point P is 0, 0, 0. And we know that our line is perpendicular to this plane. So if this is our line, it is perpendicular to this plane. Well, okay, so we have to use that information to find a parallel vector for the line V. But what you should remember is that when equation of plane is given in this form, this is, remember, called standard form. What kind of information you can see there? I can say right away that a normal vector is the vector you form by the coefficients of x, y, z. So it will be -2, 1, -2, and -1. This is normal. This is a normal vector for the plane. And we know that the normal vector is perpendicular to the plane. Well, what does that has for us? Our line is perpendicular to the plane. Normal vector is perpendicular. As a result, our line is parallel to the normal of the plane. So let me just write this here, explain it here. So n is perp to the plane. Our line is perp to the plane. As a result of that, n is parallel to our line. Well, means what? Means that we can use the normal, which is 1, -2, and -1, as our parallel vector and write the equation using that. Well, xt equals to p plus tb. In this case, xt is equal to 0, 0, 0 plus t times 1, -2, and negative. That's it. How about the third part, the last part? We are looking for 2-point form for the line given by this point parallel form. Well, remember that for 2-point form, we need 2 points, P and Q. This equation, which is the equation of the line, we are basically switching the point parallel form into 2-point form. How do we do that? Well, look at the point parallel form. It is P plus TV, yes? It means what? This means that this is a point on the plane, on the line, and this is parallel vector. So this right away tells us that, well, okay, here it is. This is 1 point. How about the second point? Well, second point of this line, you can set t to be any number and then find xt for that specific t. Well, just exclude 0. Any t but 0 will give you another point on that line. But specifically, it's better to find x at 1. x at 1 will be negative 4 to 1. This is the vector of that. Plus 1 times negative 1, 3, 2, which gives us negative 5, 5, and 3. Well, we found the second point, the first point, second point, and then remember for the 2-point form, we do 1 minus t times p plus t times q. Well, it is here now. This is 1 minus t times p and t times negative 5, 5, and 3. And that was the the last example for us.